welcome back to our channel. Today we are going to explain you about the different parts used in an moving coil instruments as well as moving iron instruments. So currently I am going to explain the different parts used in an moving coil voltmeter and moving iron ammeter. Now let us come to the detailed explanation. So here you see here, so this red color wire we are going to give the positive of the supply, and to this black color one you are going to give the negative of the supply. Similarly here you will connect the phase and here you will connect the neutral. Now let us try to see the different parts what we used in our used in an voltmeter. So this is nothing but a moving coil voltmeter, and you can see here a bar is written, indicates that this will measure DC quantity, and here also you can see here a line is there which indicates that this is going to measure DC quantity. But when you come to the ammeter, this is an ammeter and this is going to measure the AC quantity. Okay, so since it is an symbol is shown like this, you can confirm that this is an moving iron instrument, this is a moving coil instrument. Now coming to the parts, so here we are going to have the parts that are used. Okay, it's very tough to directly show you, so that's why we have been dismantled and we are showing the original. So coming to here, this moving coil instrument is similar to that of the functioning of an DC motor. So here you can see here, so this is nothing but so generally we will be having stator and rotor. So this is nothing but our stator. Let us assume that, so this is nothing but our stator, where the stator is called as field winding, and we will insert our rotor inside where this is called armature. Now I am going to bring this stator, I mean the field winding, to the inside and the armature to the outside. Okay, so now you see the same here. So now, so this wire, okay, you can see here, so the wire will start at this point, and this is called control arc, or this is called as a prosperous branch spring, and it is connected to the coil, and the coil is bought out. Okay, so this is how we had bought the coil outside, and the center part will act as an permanent magnet field winding, and the outer part, this is nothing but the outer part, so this outer part will act as an armature. Okay, so this is how the construction is there. This construction and design is similar to that of the parts of an DC motor. So now you can see here the same is available inside the meter also. At the bottom we are going to give the positive terminal and the negative terminal is bought outside. So this is how the parts are there. Okay, so hope you can see here, this is nothing but our pointer. Okay, so as soon as you move your pointer, so automatically due to control torque it will come to 0. So this you can observe here. So since it is damaged, it is not functioning. So now as soon as you apply the current automatically, you can see here our meter will indicate, this is called deflection torque. As soon as the deflection torque comes to 0, it will come to the original condition. This is called control torque. Okay, so here we are going to produce the control torque. You can see the spring, so this is called as a prosperous branch ribbon suspension spring. You can see here a spring type element is there. This is going to produce the control torque. Okay, so what I am showing here, so this is nothing but the control torque which is going to produce with the help of spring. Okay, so coming to here the parts. Okay, so the center one, okay, so the center one is nothing but a permanent magnet, and the outer one is nothing but the coil. Okay, so which is nothing but the coil which is nothing but armature which is there, and as soon as you give the supply, automatically it will produce the deflection torque like this, and as soon as you remove the supply, it will come to 0. So this is how the control torque and deflection torque is produced. And coming to the difference, you can see here, so this is an moving iron instrument, this is an moving coil instrument, and we already say that moving iron instruments has an non-linear scale. Here you can see here, so here the scale is distributed 0, 1.1, 1.2, and these are having more number of readings and lesser one, and here after 4.5, so you have less amount of division. So here this region is a non-linear region, and this region is also a non-linear, but the region from 2 to 4 is a linear region. So that's why these MI instruments are called non-linear scale, as well as MC instruments are called linear scale. Here you can see the scale 10, 20, 30, 40, and it is linearly distributed up to 150. So how to give the terminals to our meter is, so here you can see here, so this we have to connect to 30 volts. Okay, so this positive you have to connect to 30 volts and this negative you have to connect to the negative. Automatically if we connect 30, we have been connected in the range of 150 as well as 300. So here you can see here, so there are two types of ranges. So when you connect to 150, so you can take the multiplication, I mean the multiplier as 1, and how to convert 150 into 300 is just square it 2 times. I mean 150 into 2, automatically you are going to get 300. So then if you want to measure 300, just change the settings to here. Automatically it can measure and voltage up to 300. Same you are going to have here also. Okay, so but the type of instrument is going to change. So this is nothing but a moving iron instrument. So this is how we are going to connect the phase. Okay, for example, I want to connect phase, you connect here, and the neutral you connect to the common port. Okay, so automatically this is how to give the connections. Now coming to the different parts that are used in an ammeter, we will discuss in another video. So thank you for watching. We will meet in another video discussing about wattmeter also. Thank you for your time. We will meet in another video.